Welcome back from the previous episode where we spoke about method area, PC register, and native method stack. This one we're going to speak about stack and heap, so let's get into the presentation. Runtime data area, stack space for each thread has its own workflow as first in, last out call, that structure. It contains all the information about what methods the thread has called to reach the current point of execution. Contains all local variables for each method being executed. All local variables of primitive type especially stored on the stack thread and are not visible to other threads as well. It grows and shrinks as new methods are called and returned respectively. It is automatically allocated and deallocated when the method finishes execution. If this memory is full, Java throws java.lang.stack overflow error. Getting into heap space or heap area, it is shared across multiple threads like objects and array for memory optimizations. It stores class instances and arrays created when the Java virtual machine starts up. It has a string pool space. A string pool is so important to be in heap, and string pool is one of the main power of Java, that because you don't need to create multiple string variables with the same value, because already in a string pool you can store one string, then later on if you would like to assign another object the same value of that string, you can just reference to that value in a string pool. By this way you will have a memory efficient and optimized using the string pool for reusable strings in the future. Heap area has its own architecture as well, so let's get into the heap area architecture, starting by consider this block as the heap area space. So we have here young generation, old generation, and permanent generation, PermGen. For young generation is divided into Eden, Survival 1, Survival 2. What's going on here? When your application starts working, it will fill Eden with the object which created for the application to run. After a while, you will have a minor garbage collector which is going to check Eden, Survival 1 and Survival 2. If there is any object for deleting, it will be deleted. For first time, Eden will move all this object into Survival 1. Make sure Survival 2 is empty. And after a while you will have another minor garbage collector to make another check till Eden, Survivor 1 or Survivor 2 get full. It will move to Survivor 1 or Survivor 2, but it should make sure that one of the Survivor is always empty. You can control the size of the young generation by -xms to control size. Also the heap in general by -xms for minimum size and -xms for maximum size as well. After a while, from the minor garbage collector running over young generation, if it's already full, all the old object from young generation is going to move into the old generation area of heap. Then after a while, we will have a major garbage collector cycle, and this major garbage collector cycle will make sure to clear the heap area from any object which has no reference to it or has no use. By using the garbage collector, you avoid the issue of what to do if your object isn't used anymore. Java is doing that for you by using the garbage collector. Let's get into more detailed workflow so we can have a better glance of how it looks like. You saw it now as a presentation. Let's get into text. Heap area workflow starting by newly created object stored in Eden area. When Eden get full, a minor garbage collection will start. After the minor garbage collector check also S1 and S2, then keeps one of them empty all the time. The survived object moves into one of S1 or S2. Object survived many garbage collector cycles moved into all generation space. Usually it is done by setting a threshold for the age of the nursery objects before they become eligible to promote to the old generation. When the old generation becomes full, a major garbage collector will start. Usually it takes longer time. There is a famous term called stop the world. When the garbage collector started, the application will stop for a few milliseconds to finish cleaning your application, then will start again. But you are as a user, you will not feel this stop. For the PermGen area, which was used before Java 8 and it is part of the heap, it contains all the application metadata required by the Java virtual machine to describe the classes and methods used in the application. Also contains Java standard edition libraries, classes, and methods. Objects are garbage collected in a full garbage collection. We have now heap area, what we call it Metaspace. It is not PermGen anymore because Metaspace replaced already PermGen since Java 8 and is not part of the heap anymore. By default, it auto increases its size, depends on the underlying operating system provides. And the lifetime of classes and their metadata matches the lifetime of the class loaders. You can use -xx metaspace size and -xx maximum metaspace size flags to control the size of your metaspace. Metaspace now is part of the operation system, so it is more memory optimization, more memory efficient. We have done already with run data time area. Next time we are going to move into the execution engine and how execution engine works exactly in Java. So stay tuned. See you next time. Peace be upon you.